Hi, hello, namaskaram. Myself Mahesh Prasad from Department of Physics, as you know. So we have covered about a number of topics like uniform velocity, uniform acceleration, and change in acceleration, average velocity. So these are the basic concepts we have studied so far, correct? No. So based on this particular concept, we will try to get the graph of this particular concept. Okay. So today's class we are going to study about graph by plotting like the position time graph as well as the velocity time graph as well as acceleration with respect to time, how it varies, and by looking at the particular graph we will get to know how exactly the particle is moving from one position to another position. So this is the beauty of this particular graph over here. Okay, so we will see one by one. So firstly we are going to deal with the position time graph, which means in the y-axis we are taking as the positions as well as in the x-axis we are going to consider as time. So with respect to different time, what exactly the position we supposed to get, we will get to know. So the first one we are dealing, that is the xt graph. So what is the xt graph? X which deals with the position and t which deals with the time. So normally we should take in the y-axis, let us take it as a position. In the x-axis, we will take it as a time. So in the y-axis, what we have? Position as x over here. In the x-axis, we have time over here. So now the thing is, your job is to plot a graph versus xt by having a scenario like body which are at rest. Body which are at rest in the sense what? Time is running. At the meantime, the body which are at rest. For a time being, am I moving or am I standing over here? So which means time is running with respect to my position, correct? No? So similarly, I can expect the graph somewhat like this. So this is a graph which says like if time starts from 1, 2, 3, 4, 5, if the position I have covered as the 5 meter, like 1, 2, 3, 4, 5. The time is running, but the thing is I have covered only the 5 meter. Are you getting? So this is the time I can expect, or this is the position I can expect over here. So this is a way of representing position time graph. So next thing is we supposed to plot versus the graph versus uniform velocity, or the body moving with the uniform velocity. What do you mean by uniform velocity? Which means a position covers equally with respect to a time. So as we know, this is the y-axis which represents the exact position, and this is the time, which means body covers equal position in equal interval of time, correct? So if we say it is a uniform velocity, I can expect the graph somewhat like this. So this is a way of writing the graph over here. Okay? So this is a way of writing graph, which means in the y-axis we have a position, in the x-axis we have a time. So this is nothing but uniform velocity, which means for each particular time, uniformly it is moving. So what like this? For example, 1 second, 1 meter, 2 second, 2 meter, 3 second, 3 meter, like that. It is moving uniformly. So similarly, we can plot a graph versus body moving with the increasing velocity or uniform acceleration. How to plot this? That is, you take the same scenario. That is, in the y-axis we have position, and in the x-axis we have what? A time, and look somewhat like this. And how to do this? This is like increasing velocity somewhat like this. So this is the position. So as the time moves, its position also increases, correct? Its position also increases. So variable, it is not going to match up with the equal interval of time with respect to its position, which means velocity is increasing. So similarly, how to get the decreasing velocity? How to do this? That is once again we need to do. This is the x-axis and this is the y-axis. As we know, in the x-axis, what we supposed to plot over here? That is time. In the y-axis, what we need to do? That is position for timing, because we are plotting a position time graph, xt graph. X means what? Position. That's what. So how to do this? It's very simple. This looks somewhat like this. So this is a representation of position time graph where velocity is decreasing with the uniform retardation. What is the retardation? Which is nothing but deaccelerating the position acceleration over here. Okay, so this is how exactly we are doing under the concept of this particular xt graph over here. Well, dear students, we will move on to the one more topic, that is your job is to plot graph versus velocity with respect to time. How exactly we will see now. So before the case we have discussed by plotting graph versus position versus time. Now the thing is your job is to plot versus what? Velocity with respect to time. How a particle moves by varying velocity or a constant velocity, we get to know over here. Okay. So this is how exactly we need to do under the particular case. We will go one by one. The first case it says that velocity of a graph, if the body is moving with the uniform velocity, how to do this? Which means it is a similar case like by plotting y-axis as a velocity, x-axis as a time. So which means the body is moving with the uniform velocity, which means this is how exactly I can explain. And don't get confused with the position time graph with this particular velocity time graph. And here we have a uniform velocity with respect to time, which means a constant velocity. Like with respect to time, the body which is moving with the corresponding velocity, corresponding position which covers over here. And similarly, the next one says the body is starting from rest and moving with the uniform acceleration. How to do this? Let us plot a graph somewhat like this. This is the x-axis, this is y-axis, and this is the x-axis. You take the y-axis as a velocity and x-axis as a time. As per the given scenario, the body should start from 0 or rest over here, and it should move with the uniform acceleration. And this looks somewhat like this. This looks somewhat like this. Okay. The body which is started with the initial position and the body which is moving in a uniform acceleration. And the next one which says the velocity time graph. If the body is having some initial velocity, which means the body is not started up with the 0 over here, which means it is having some initial velocity. Then the body which is moving with the uniform acceleration looks somewhat same. We plot the y-axis, x-axis, then here is the velocity and here is the time. The body is already started up with the initial velocity, which means this is the point at which the body is covered already initial velocity. Then it moves with the uniform acceleration. Don't you think these two are a similar concept? And here the body which is started up with the 0, whereas here body which is already covered some distance, which means it has covered with the particular distance with the particular velocity, which means which is having some initial velocity. So after that, it started up with the uniform acceleration. Okay. Next one is the velocity time graph. Body which is moving with the uniform retardation. What is the retardation, by the way? You are moving. For example, you are driving a car. Suddenly, if you press a brake, if brake is working, so if it is working in the sense, if you press over there, suddenly his car is going to stop. No? So that particular scenario we can expect as a retardation. We are de-accelerating. We are not at all accelerating the motion. So that's why if we have such kind of things, we can have graph somewhat like this. That is velocity with respect to time. If I plot over here, what I suppose to do? Retardation. Retardation comes over here somewhat like this. This is how exactly we can expect. The body is going to de-accelerate, which velocity is going to decrease. Correct? No? Yeah. So next one is the body is moving, or body is having a variable acceleration. How to get a variable acceleration? Do somewhat like this. That is, this is a y-axis, this is x-axis, velocity with respect to time. I can have what? How to do this? That is somewhat like this. This is a variable acceleration I can expect with respect to velocity with respect to time. And one more thing I can have, that is what I can have. The area under the particular VT graph, which gives what? Basically, which measures a displacement. Okay, that's it. Yeah. And one more thing you need to remember, that is the slope of a velocity time graph which gives acceleration, which means as we know, if I take a slope of this which gives, let us say A, B, C, BC by AB gives what? Acceleration. This you have to remember. Okay? And if I take area under this particular VT graph gives what? Displacement. Okay? So this is what I wanted to tell over here. Yeah. So one more concept, that is one more graph we need to plot, that is acceleration with respect to time. Okay. So obviously when the particle is moving, it can have a uniform acceleration or a variable acceleration or a constant acceleration, so or retardation. So these are the basic concepts we have already studied. So based on those particular concepts, we try to get the graph of graph versus acceleration versus time. Okay. So normally acceleration in the y-axis and time with respect to along the x-axis. So we'll get that. So you plot along y-axis as well as x-axis. Your job is to plot what now? AT graph of a body. AT means acceleration time of a graph of a body. If it is moving with the uniform acceleration, if the body which is moving with the uniform acceleration, how to plot this? Looks somewhat like this. This is a way of getting uniform acceleration. Okay. And one more, that is a body, if it is moving with the increasing acceleration, how to plot this? If it is in increasing acceleration, y-axis, x-axis, the y-axis we suppose to represent as A, in the x-axis, let us say T. If it is moving with the increasing acceleration, in the sense what? Somewhat like this. This is a way of writing increasing acceleration. How to plot the similar way in increasing acceleration? So you plot x-axis as well as y-axis over here. So now the thing is, in the y-axis we suppose to take it as what? A, and the x-axis we suppose to take it as a t. If it is moving in decreasing acceleration, in the sense what? Somewhat like this. So this is the way of writing decreasing acceleration. And the next one. The graph is, if it is moving in a variable acceleration, how to get this? Looks somewhat like this. So this is the way of plotting the graph. In the y-axis we have acceleration, in the x-axis we have time. So A versus T. If it is moving with the variable acceleration, means what? Somewhat like this. So these are the basic concepts I can expect by plotting the graph versus acceleration with respect to time over here. So we have discussed about position time graph, means by varying a different position with respect to time, how to get the particular position time graph. Also we have discussed about velocity time graph. What is the velocity time graph? Velocity means by changing the position with respect to time. Obviously we can have a uniform velocity, we can have a variable velocity, we can have an instantaneous velocity. So by plotting this particular graph, you will get to know how exactly the particle is moving from one point to another point. Similarly, we can say that whether the particle is moving by seeing the AT graph, we can get to know whether particle is moving with the uniform acceleration or a decreasing acceleration. Somewhat over here, this is a decreasing acceleration. Also here increasing acceleration, and here we can have variable acceleration. So this is how exactly we can get under the concept of different types of a graph over here. Okay, thank you very much.